I'm going to do a slightly abbreviated version of this talk. This is called How to Be Fast, a look at high-performance websites. This talk was supposed to happen yesterday, but I don't know if y'all remember, there was a bit of an evacuation situation, and so this is when we got rescheduled for. So my name is Eric Brandis, and I build software that monitors other software. So the main product that we've made, my business partners and I over the years, is Track.js, which is a JavaScript error monitoring tool. But our JavaScript error monitoring customers kept saying, hey, we want to know our performance metrics too, right? We want to know not only do we have JavaScript errors, but is our website fast? And we didn't have a good way to answer that question for them. And so we built a second product called Request Metrics. And so my head has been in the web performance space for the last 2 years while we've been building it. And so this talk is all about ways to go faster, how to measure speed, and how you can make your website faster. Why do we care about speed? So just yesterday, I was telling somebody about this talk, and he said that where he works, they don't care about speed because the users of their software are paid to use the software. And so it's like, we don't care. And I was like, well, but I feel like as professionals, we should probably have a little pride in our work. And if that doesn't sell you, years and years ago, Amazon did a bunch of investigation into performance, and they found that for every 100 milliseconds that the site was slow, it cost them 1% of their sales. And in fact, Walmart just saw the exact same thing a few years ago. The BBC, they noticed that for every additional second the page took to load, 10% of the users leave. And Google is on the same track as well. So if your page load goes from 1 second to 3 seconds, the probability that the user bounces goes up 32%. But if it goes from 1 second to 6 seconds, the probability of a bounce is 106%. So users don't like waiting for slow things. And when we talk about speed, so what does it mean, what makes a website fast or slow? We should probably discuss some terminology. So for years, the main barometer of web performance was load time. And so the load event is fired at a certain point in the page lifecycle when all of the dependent resources are done. And so when we talk about performance, a lot of what we're talking about is load time. And so if you've ever looked at the Chrome developer tools, on the network tab at the bottom, it will tell you the load time for the website that you just loaded. It will also give you DOM content loaded, which is when the DOM is parsed and in memory, but not all of the dependent resources have been downloaded. So both are interesting numbers, but really load is historically the thing we care about. However, Google recently has created a new thing called the Core Web Vitals. And I'm not even going to read that paragraph to you because it is so much marketing speak, I can't even stand it. But there are 3 Core Web Vitals: largest contentful paint, first input delay, and cumulative layout shift. Now, these measure different parts of page and website performance. The thing that we mainly care about today is largest contentful paint. And we're going to talk more about what that is in a second. But there is also a 4th Web Vital. It's not a core Web Vital. There's only 3 of those, but one of the other Web Vitals is first contentful paint, which is related. So if we use bbc.com as an example, if we go to webpagetest.org, right, they do a really cool thing where you can put the website in and then it'll show you a series of thumbnails as it's loading. And they will actually call out first contentful paint and largest contentful paint for you. And first contentful paint is when the very first thing, whether it's a text or image or whatever, is rendered on the screen. And the idea with that is, you want that to be as fast as possible so the user can tell that something is happening. Largest contentful paint is the paint that is the biggest area of the screen prior to load. So here we can see in the BBC example that big hero image is the largest contentful paint, the biggest paint that happens before load. And the idea with largest contentful paint is that the faster that is, the more likely that your website at least looks usable to the end user. So Google says it should be less than 2.5 seconds, which, if you've used modern websites, not many people are doing it in under 2.5 seconds. And Google is serious about this stuff. So in 2010, they started using load performance as a signal in search result rankings for desktop websites. In 2018, they added mobile performance as a search result ranking factor. And as of 2020, the Core Web Vitals are now actually included as a ranking factor for your search results. Now, they're cagey. They don't say how much of a factor it is. They just say that they're going to continue to use it as a factor. But it's important to know about these core web vitals and measure them so that you can make sure you're not going to run afoul of Google, big G. When we talk about web performance, there are 3 big factors outside of your control. The first is what device your user is using. So some people have super modern smartphones or Apple M1 Pros, and they're awesome. And some people have 8-year-old Android 4 phones, right? And that is going to make a big difference in how they experience your website. It's also a matter of the connection. So if you're on like a super hardwired fiber to the home connection, your internet experience is going to be a lot better than somebody that's on dial-up or on the tube and is like getting the most spotty internet ever. And the third thing that we can't really control for is where the user's coming from. So we don't know how far away they are from our servers, but the further away they are, the worse the experience is going to be for them. So in order to fix and mitigate those 3 factors, we need to measure performance first so that we know how are we doing today, and then we need to speed things up and so we can measure if we've actually improved things. So in the School of Web Performance Measurement, there's 2 thoughts. You'll hear a lot of people talk about lab measurement or synthetic measurement. And I call these theoretical measurements because they are totally bogus. And the biggest purveyor of nonsense performance audit data is Lighthouse. And so this is a tool that was created by Google, of course. Like 30% of the stuff in this talk was created by Google. And I call it the thing that everyone uses for made-up results. So if you've never used Lighthouse, you can find it in your Chrome developer tools, right? It lives right here. And it lets you run performance audits on the site that you're currently visiting. And you can see you get some categories that you can choose from. One thing that most people don't know, because this is actually hidden most of the time, you actually have to open this menu. By default, Lighthouse uses what's called simulated throttling, where they do some sort of black box network throttling to try and appear like a real user would. But what does that mean? Now, you can uncheck this, and they won't do that. But regardless, if you pick mobile, they're going to do more emulation to try and emulate a mobile device. And that includes things like throttling and trying to sort of mimic the user agent and other things. It's not always perfect. So, for example, here is Google.com search results for web performance. Now, I don't need a website or Lighthouse or anything to tell me that Google search results are fast. Every time I search and hit go, it feels practically instant, right? So what does Lighthouse, Google's own tool, say about Google.com? They get a 66 on the performance score with a big orange color, which means it's not very good, right? Now these scores are, they're out of 100. What does it actually mean? They've got this rubric for calculating them. But the big thing that I found really ironic, deeply ironic, was that their SEO score is so bad. Right? This is the company that writes the book on search engines, and they can't optimize it. Maybe they don't have to. And you can see their largest contentful paint, and you can start seeing some of these web vitals in these Lighthouse audits. Their largest contentful paint is 2.9 seconds. Well, remember, I just told you that Google themselves says you should have a largest contentful paint less than 2.5 seconds, so they don't even pull it off, right? So then I was like, well, okay, maybe this is just, I need something to compare it to, right? I don't know what a 66 means as far as performance score. I just know it's orange, and that's not very good. So I was like, well, what is like a really dog-slow site that I can run Lighthouse on? Like, what's the worst site I can think of? And I was paying my credit card bill at the time, and so I was like, yeah, chase.com. This is one of the worst websites on earth. And when you load chase.com, it's so bad that there's so many loading spinners. This is just 3, there's 7 loading spinners that spin when you load it. And I'm like, surely this will get worse than a 66 performance score. So I ran Lighthouse against it. And it gets an 80, which is unbelievable. And they nailed the SEO game, right? I mean, Google can't do it, but chase.com can with all those loading spinners. Are you kidding me? And then you can see the largest contentful paint is 3 times faster than Google's in Lighthouse. And I don't think that's right, because every time I use that site, it's terribly painful. So the whole point of this is just to say that it's not always accurate. And to prove it, there's a second kind of measurement. It's called field measurement. It's actually getting the values from the user's browser when they load a page. And of course, Google also has that data. So I don't know if y'all know, but Chrome is sending statistics for your page loads back to Google. And they call it the Chrome User Experience Report. And so Chrome is sending back all of this performance metric data. And you can put in a web page URL into their page speed insights UI, and it will give you back a performance audit report that looks a lot like Lighthouse, but it's actually using real data. So let's look and see how things go. So here is the Chrome user experience report for Google search results for that query. You can see that they've passed their Web Vitals assessment. Their first Contentful paint is blazing fast, and their largest Contentful paint is 3 times faster in real life than Lighthouse said it was. And if we go to Chase, the world's worst website, they fail their core Web Vitals assessment. The first Contentful paint is in the orange, and their largest Contentful paint is in the orange, and it is 3 times slower in real life than it is in Lighthouse. So the main point here is that those synthetic measurements, they might be useful for certain class of investigation, but in my opinion, the best way to measure web performance is get the data from real users. And so you'll hear the term real user monitoring thrown around a lot. That is often a performance monitoring plus sort of activity monitoring, tracking clicks and that kind of thing. So in this case, I'm talking about real user metrics. And we can get all of the metrics we'd ever want from the browser itself. So all modern browsers, including some older versions of Safari, support the window.performance API. And so here's just like a quick little throwaway one-liner to get the navigation entry for whatever page I was on. I think that was bbc.com. But you can see here the duration is actually, that is the value of page load, right? So you can do this in any browser right now. You can put that in, and you'll actually get all of this detailed information. I mean, to like, how many decimal points is that? Of how long did load take. You can figure out how long did SSL take. You can figure out what kind of protocol were we running. Was it HTTP 1 or HTTP 2? And so we took all this data that was just sitting there waiting for us. And so what Request Metrics does is it actually just packages it all up, right? And sends it and makes pretty graphs. And so the goal is to show you what is not only your 50th or median percentile, right? But what is your 75th percentile and 95th percentile for load? Because it's in those margins where your users are going to start to see poor experience. And we can also use the browser to give us Web Vitals data. So there is now a performance observer object that you can use in Chrome and Firefox mostly, and a little bit of Safari. So the browser support is not as good, but you can get largest Contentful paint, you can get cumulative layout shift, you can get all of the core Web Vitals from this, at least in Chrome for sure. And so we send those to our service too, because what we want to see is how are we doing on this stuff, right? Like this data is only interesting in aggregate, right? Like one person might have a bad experience, but how about 100 people, right? So now that we've talked about all this like terminology and stuff, what are some tricks that we can use that like the big guys use, like Google, to be fast, right? And so some of this stuff is, you're gonna be like, yeah, this is like brain dead common sense, Eric, and I know that. But I still see a lot of people not doing it. So the first thing that we can do to go faster is just do less, right? Just make less requests. So even Google itself loads something like 39 assets when you go to their search result page. But you know who doesn't load a lot of things? Gov.uk. So I was not planning to include gov.uk in my talk until I came to this website from my house in Minnesota, USA. And I was like, this is the most fast website I have ever seen in my life. And I was like, what are they doing? Like, it's a really simple site. I know it's a lot of text. It's pretty basic functionality. So it should be fast, but it is really fast. And I'm looking, and they only load 17 things, which is crazy. Like, that is the lowest I've seen on any major like public-facing website. It's only 200 kilobytes over the wire, and you can just see that like load is blinding fast. 223 milliseconds is crazy, and that's from my house in the US. So we're gonna talk about that more later. And I was also like, man, every time I go back to the website, it's really fast. And so one of the things that I see people screw up all the time is caching, right? So if we look, so I loaded gov.uk for the second time because I wanted to see how they did on caching. And you can see that literally every one of the static content assets came from the cache, right? So hurrah, they've got it configured right. But what's more interesting, and I don't see this hardly ever, but this is cool, and y'all should think about it. I went to www.gov.uk, and you can see here that my browser only got 81 bytes back from the server. It knows that the HTML is 82 KB, right? But it only got 81 bytes back. And that's because they have their E tags configured correctly, and we got a 304 back instead of a 200 with all that content, because when we made that request, my browser sent an if none match header with the E tag that it had retrieved last time. And as long as it didn't change, It'll send a 304 back, and it'll just pull it from disk cache, right? So I rarely see this in the wild, and it's great. And of course, the people who built this site, they did it all for the static content as well. So there's a couple things I want to call out just in terms of getting your cache control stuff right. There's sort of two pieces of the puzzle. The first is you need to use the right cache control header. In this case, they've got a huge max age. So max age is measured in seconds, right? And they've got, I don't know what that is, it's like 15 years or something. And they've also marked it as public, which means that downstream proxies and caches can cache it. And they've also marked it as immutable. And I don't see too many people using the immutable keyword, but it is really nice. It's a little bit newer, and it just tells the browser as well as downstream caches that like this thing will never change. Like if there's a new version, it'll have a new file name, right? You can safely conclude that this will never, ever, ever change. And they also put a far futures expire header on it, right? So that's 15 years too, I think, right? December 2037. And so those two things mean that my browser, as long as the cache exists on disk, as long as I haven't cleared it, it will never go back over the wire for these assets. And when they change, they'll just update. It looks like they got commit hashes or some kind of file hash in the name. Whenever the file changes, they'll just change the file name, right? So this is easy stuff, but a lot of people don't do it. Same thing with smaller files, right? So I say compress everything. Everybody knows that, right? Except for, like, I've got this JavaScript here. I know it's tiny. The point is not to read it. The point is that I'm going to put it in a minifier. So if we uglify.js it, we actually take that little bit of JavaScript, and it goes down 66% for minification. And I would say broadly, we see about a 60 to 70% size reduction in minification in general. And you're all saying, yeah, we minify. Except, a lot of times, I see people are like running Webpack builds, and they forget to put it in production mode, right? And so they're actually sending out inline source maps and all sorts of just terrible stuff to their production website. So it's one of those things like just make sure you check the box. And then if we look at our friend Google here, so I was curious, what does Google do as far as compression goes, right? And I kind of knew the answer, but I wanted to check. So when my browser, Firefox in this case, because I wanted to see if it was supported, made a request to Google, it said, hey, I'll accept these 3 different kinds of content encodings, right? You've probably seen gzip and deflate before. And if you're in the web space, you've probably heard of Brotli or BR, right? And sure enough, they gave me back Brotli, right? And so does gov.uk, for example. And so I didn't actually know what a Brotli was. I'd heard of this for years, but I didn't actually know what it was named after. It turns out it's a Swiss pastry of some kind. That's what Google image search comes up. So I don't know if that's right, but that's what they said. And the reason you might consider Brotli instead of gzip is because it does, on average, give you about a 20% size reduction in HTML, and it's about the same CPU time as gzip, depending on settings, right? So you're basically paying the same cost, but getting a slightly better compression ratio. So Brotli is a thing that if it's easy, if you can just change it in your framework, might be worth it, or on your web server. So if we look at compression in real life, so we have to do this for request metrics, the product I build. So we have a JavaScript agent that we have customers put on their websites to get all of that metric data. The original size of that JavaScript file, it's like a big Webpack TypeScript thing, it's 46 KB. Once we minify it, it goes down to 16 KB or 65% savings. Once we gzip it, we save a further 10 kilobytes. And so we've actually saved 83% of the bytes over the wire. I also tried it with Brotli just to see, and you get about a 6% improvement over gzip, which in our case is probably not worth it, right? I think there's other things we could do probably if we cared. But it's just, frame of reference. One last thing that I bet, especially in Microsoft world, you're probably not doing is compressing your JSON API responses. So for years, ASP.NET MVC and MVC Core did not automatically turn on gzip compression for JSON responses. You can, but it just wasn't on by default. I don't know what the default is today, but it'd be worth checking because JSON is eminently compressible, right? And so you could get a lot of performance savings just by turning that on, especially if you're doing single page applications where there's a lot of API calls, or if you're using something like GraphQL or whatever. So let's talk about images for a second. So images, the general rule of thumb is you can't compress images, right? They're already compressed. The whole point of the image codec is to make the smallest possible binary representation of this image. But that's not quite true. If you've never used TinyPNG, you should try it. So if you have a PNG image and feed it to TinyPNG, they will give you back a PNG that's even smaller but looks identical. And supposedly it works with WebP and JPEG too. I haven't tried it with those. But there is a Visual Studio Code extension where you can just right-click on the image and say, send to tiny PNG, and it will just come back fully compressed. So it's pretty easy to do, and they have full CLI and API integration too. And if you haven't seen WebP before, Google loves using WebP because they invented it. And it's cool, though, because it is 26% smaller than PNGs, and it does support some things that PNGs don't, like animation, right? So it's kind of meant to be a replacement for animated GIFs and PNGs, and it supports alpha transparency. So it can do a lot of things. Google almost exclusively serves WebP to modern browsers. The problem with WebP is that it's not fully supported everywhere. So Firefox, Google, and new Safari all support it just fine, but there are some old laggards where older Safaris will show static images, but they will not show the animated ones. IE doesn't support it at all. I don't know how many people still support IE, but the other thing that you can do as far as images go is you can send different sized images to different devices, depending on aspect ratio, width, viewport width, or resolution. So back to Google, if we look at their logo, right, and if we expand this out, they've got the usual image stuff, right? They've got a source, but they've got a new attribute called source set, right? And it's new, it's been around for a few years, but it's pretty widely supported now. And you can see here, they've actually specified 2 images, one with 1x, or sort of normal resolution, one with 2x, or high DPI, like Retina style, right? And so I was requesting with my crappy Windows desktop, and I got the 1x version because it is not high DPI, which saved me a bunch of bytes over the wire. So if you do have an image-heavy site, it might be worth considering using source set and sending smaller images. You can also, instead of 1x or 2x, you can put in widths. So like if the viewport width of the device is 480 or less, send down this small image versus the full desktop image. And that is a great way. It's a little bit of work, but it's a great way to lower the amount of bytes over the wire. And the last image trick is Google does this a lot. I don't see it very often anywhere else, but if you have small images like these, so when I searched for web performance, these 3 images came up. If we look at this image and inspect it in the browser, right, we'll find out it's not actually living on a server somewhere. They sent me base 64 encoded data, right? They're using a data URL. So there was no request made to get this image. They included the entire binary source of the image in the response from their server. Now you can see the file size is only 4.5 KB, and they only do it for small images. Especially when they have a lot of little small images. And the reason is because anytime you base 64 something, you're going to increase its size by 33%. So as things get bigger, you're not going to want to pay that 33% increase. You'd rather just make another request for it, right? OK, so now I want to talk about proximity and things you can do to mitigate people that are far away. So the way that request metrics works today, right, when someone goes to visit our app or sends data to us, if there's 2 servers that live in Montreal, Canada. So no matter where you are in the world, you are talking to a server in Canada, right? So from the UK, it's going to be slower than from somebody in, Toronto or whatever. So like, wouldn't it be cool if we could have multiple locations, right? And obviously you can, so I'll get there. But the nice thing about multiple locations is then your users don't have to go as far. And so one way to do that, like the best way, like the way where you have full control, but it's also the most complicated, is called GeoDNS, right? And that's what Google uses, and we're going to look at it in a second. But GeoDNS takes into account the requester's IP. So when I ask for google.com, it says, where are you requesting from? Oh, Minnesota. I'm going to give you the server closest to Minnesota. Or if I'm in London, it'll say, oh, here's the London IP, right? And so they actually have full control over which IPs get returned. So if we look at it, right? So if I run NSLOOKUP from my machine in Minnesota, USA, Google lives at this IP address. If I plug that IP address into a reverse IP lookup, I find out it's in Chicago. It's 400 miles away from my house is where Google lives for me. The speed of light can do 400 miles in 2.1 milliseconds. How long do you think it takes to do a ping, right? And so just as a quick aside, a ping is a single packet going over the wire and coming back, right? So it's only 32 bytes. And it doesn't even use TCP or anything, it uses ICMP, so it's quite lightweight protocol. It's about as fast as you can get. So for my house in Minnesota to talk to Google in Chicago, it takes 26-ish milliseconds, right? That's pretty good. But it's still 10 times slower than the speed of light. And I thought we were supposed to move at the speed of light, right? Everybody's got fiber and all this stuff. Well, the reason is because there's 12 hops between my house and 400 miles away in Chicago, right? And so each one of those routers is adding a little bit of latency. And so when we look at loading Google, we can see that it's 45 milliseconds to do the SSL handshake, which isn't too bad. We're not waiting for very long. Content downloads half a second. The whole thing is done in 750 milliseconds, right? That's pretty good. So then I set up a computer in London. I was like, well, how long, like if I'm in London and I say, where is Google? What does it give me back, right? Well, it gives me back a different IP address. So I looked up this IP address, and this IP address is right in the heart of the city, like City of London. And so Google, of course, has servers everywhere. So when I ping it, look at the ping on this guy. So from my machine in London, which is in the DigitalOcean data center, to Google, it's only like 2 milliseconds. Like those machines have to be very close to each other. So then I got to thinking, well, how much does proximity actually matter? What if I take that IP address, right? I take that IP address that's in the City of London. What if I take that and make that like my hosts file for google.com, right? So that like from my house in Minnesota, I'm actually talking to Google servers in London. How long, how big of a distance is it, and how long does it take? So it's about 10 times greater physical distance as the crow flies. So it's about 4,000 miles. The speed of light can do that in 21 milliseconds. What do you think the ping's going to be for this one? It's not as bad as you think, actually. It's like 105 milliseconds, so it's 5 times slower, not 10 times slower. You know what I mean? Like you might expect. And the reason is there's more hops. There's 12 hops to Chicago. There's 18 to London. So there's not 10 times more hops. There's only 50% more hops, actually. And so one of those hops is a big, long fiber cable across the Atlantic. And so you really don't take as bad of a hit as you'd think, but a 5-time slowdown is still significant. We can see that the TLS SSL negotiation takes 3 times longer, 2 times longer getting the data back, time to first byte from the server. And we see the content download actually managed to do it in a pretty respectable 1.6 times slower, and we average out about 1.8 times. So on the one hand, that's not too bad, right? On the one hand, like 2 times slower to go 4,000 miles, like that's not the worst. The problem is this is just for getting the HTML from google.com. Every other resource is going to be subject to the same performance slowdown. And those things are going to add up when you've got 20 or 30 or 40 resources, right? And all of a sudden, that 2-time slowdown starts to be a 4 or 5 or 6-time slowdown. And we do care about that. So GeoDNS is hard to pull off. GeoDNS is hard because most of us don't have global databases that span the whole world like Google does, right? We have a database that lives one place. And so no matter how many other places we try and, put servers, we still have a single point of truth generally. So this is where Anycast can come in. And so I don't know if y'all have heard of Anycast before, but what it means is that multiple servers separated around the world all have the same IP address, right? So let me give you an example. So I was really surprised that gov.uk was so fast from my house in Minnesota. And I was like, how can that be? So I decided to look it up. I said, where is gov.uk? And I did this from my machine in London, and I did it from my machine in the USA. And I got back the same IP addresses. So the gov.uk site existed, those 4 IPs. But then I pinged it. I was like, well, I'll take the same IP and I'll ping it. And when I ping it, it's 24 milliseconds from my house in the US, and it's 2 milliseconds from the UK to the same IP. Well, that's because they're using Anycast. And specifically, those IPs are actually Fastly. So that is Fastly IPs. They're using them as their content delivery network. The last point here is it's worth considering a CDN if you have a lot of static content that doesn't change very often, or even if it does. Not because the CDN is more reliable, not because their network is better per se, but because they're closer, hopefully, to your end user, right? And that does start to add up, especially the more requests that you're making. Now we get to talk about protocols. So have you guys heard of QUIC before? So this is another Google thing. Goodness. It's actually called HTTP3 now. So Google developed this thing called QUIC. It was a new HTTP-like protocol. And they liked it so much that eventually they started a standards track for it, and now it's HTTP3. And so you can see that when I go to google.com, I'm actually using HTTP3 to talk to all of their servers. And you might be saying, wait a minute, what happened to HTTP 2? Didn't we just convert everything to HTTP 2? Like, didn't Microsoft just finally start supporting it in Windows Server 2020? And of course, you're right. If you look, Gov UK is still using HTTP 2, right? And Netflix is still using HTTP 1. So I do want to just talk about the differences between the protocols real quick so that you can understand why maybe you'd want to use 2 or maybe you'd want to use 3 if it's available. Back in the HTTP days, it was one connection, one request per resource, right? You want JavaScript, you got 3 files, 3 requests. You could keep persistent connections open, but it would take server-side resources as well. Now, to get around this problem, browsers would open 6 parallel requests per domain. So clever people back in the day, and I remember doing this myself, would actually create multiple domains that all pointed to the same standard content servers so the browser would parallelize more requests, right? It was called domain sharding, if you remember. And really the problem that they're trying to talk about or get around is what's called head-of-line blocking. And it's basically all it means is that if you got 3 images, the first one is going to block everybody else behind it, right? So if I go get image 1, I have to wait for him to come back before I can go get image 2. I have to wait for that one to come back before I can go get image 3, right? And so then the smart people, they made the parallel requests. So if I've got 9 images, right, I'll send 6 requests off, and as they come back, I'll start making more requests. So that didn't really scale, and so for HTTP 2, the big change was that they no longer do multiple connections. You can now request multiple files over a single TCP stream. So that's the big difference. And in theory, it solves the head-of-line blocking problem. I can, in one TCP stream, I can ask for 20 things, and I'll get 20 things back in the response, right? The problem is, it does fix head-of-line blocking at the HTTP level, but it doesn't fix it at the TCP level. And what I mean is, so this is kind of conceptually what's happening, right? You're asking for everything all at once, and you're getting everything back all at once. But actually, under the covers, what it's doing is it's interleaving all of the bytes for all of the different files. So if you've got 5 images coming back, but say something happens, say you've got to do a TCP retransmit for some reason, right? A packet got lost. Everything is still blocked because you're waiting for all those pieces to get back. And because of TCP itself, you've still got this head-of-line blocking issue, though it is much better. Let's see how much better. So here's Amazon.com, right? And they load 330 requests. 330 things come down to draw that page, which is absolutely astounding. So I loaded it 20 times each with HTTP 1, and then 20 times each with HTTP 2 enabled in my browser. So you can see for HTTP 1, the 95th percentile actually gets pretty bad, right? You start to see some long tail things every once in a while, and median and 75th are okay. But we really start to see improvement when we turn on HTTP 2, right? Everything gets a little bit closer together. All the timings are more consistent. And because they're loading so many resources, if we look, the average image takes about 1 second to come from Amazon.com in HTTP 1 land. But in HTTP 2, it's only 312 milliseconds. So we saved, it's a 3x speed up on images just to enable HTTP 2, right? Enter HTTP 3. So now the deal with HTTP 3 is it's not even using TCP, right? They figured out, okay, that was dumb, like we'll do something different. So now what they do is they make a TCP-like protocol over UDP. And everybody gets their own UDP data stream, so that if even one of them has a problem in packet loss, the other ones don't block. So that's kind of the big thing. Can you use HTTP 3? Maybe. If you're Google, yes. If you're anybody in the Microsoft landscape, no. Caddy has full support for it. Nginx is working furiously on official support. There is a beta that you can download and will turn on HTTP 3. And if you're on IIS, well, I hope you're on Windows Server 2022, which I didn't even know that was a thing. That will supposedly enable it. As far as HTTP 3 goes, it came with another sort of trick, though. It came with TLS 1.3. So in TLS 1.2, to do an SSL handshake, you have to do 2 full round trips. In TLS 1.3, they got it down to 1 round trip. They can do 1 round trip to do the whole SSL negotiation. So right there, you're saving quite a bit of time. But it gets better. TLS 1.3 introduced what's called 0 round trip connection negotiation. So after the first time you talk to your server, they actually pre-share the keys so that the next time it talks, it doesn't have to do any negotiation. It can just start making requests. And so that can make a really big difference. Current support varies, but it's better than HTTP 3. You can start using it even with HTTP 2. It's supported widely by most web servers except for IIS. So still be waiting for that. A couple quick things. Zero RTT is not enabled by default because there are some security concerns with it. I think they're a little overblown, but you do have to enable it if you want to. And they've dramatically cleaned up the number of cipher suites that you would use. It used to be, I don't know if you guys ever looked at like the amount of supported ciphers, but it was like this huge list of just like wildly named things. Now there's only three that you have to implement. And so the last way to speed things up that I want to talk about, and then we'll go drink some more beer, is if you don't need something right away, load it later, right? Because when we talked about load time, load was fired after all the dependent resources finished downloading. Well, what if it wasn't a dependent resource? What if you said, hey, don't worry about it, right? And gov.uk does this really well, I'm going to use the async attribute, right? I'm going to load all my scripts async, and they're not going to delay page load at that point. The browser's not going to wait for them to come back before it loads. So you got to make sure your code can actually support that. But it's a great way, if you want to do things later and get your load time a little bit faster, if there are things that you can wait for. And the other thing that you can do, if you have an image-heavy site, and the BBC does this pretty well, is they lazy load images. So as you're scrolling, you don't pay to download that image until you actually put it in the viewport. Now, they have a complicated JavaScript mechanism that they're using for this. But in 2022, for the most part, we can actually use the loading equals lazy attribute, which is super cool. And so it just lets the browser say, well, once it's in the viewport, then I'll go get it, right? It's fairly widely supported. And so if you weren't doing anything about lazy loading before, it's an easy way to get started because old browsers just ignore it. OK, so the last thing to wrap it up, there's a lot of ways. There's a million knobs that you can turn to go faster, right? But in order to know if you're being successful, you have to measure it first, right? And then you have to figure out what works for your app, because not all of these make sense in all use cases, right? And there's no silver bullet. I would say the most important thing is do the fundamentals. Everyone knows them, but nobody does them. It's like flossing twice a day or whatever. It's like, yeah, I know I should do that, but it sucks. But it's worth it. And I would say that if you have a tech stack that supports it, one of the more modern protocols would be beneficial. HTTP2 for sure, and if you can, HTTP3 and TLS 1.3 are an easy way to get more performance without actually having to make any changes to your application code. And finally, it's a good idea to get closer to the user if you can. So if you can put your static content on a CDN with many points of presence around the globe and it's not too cumbersome from a deployment perspective, it might be worth it. And finally, in terms of measuring, I would say that it's really only worth it to consider field metrics or real metrics obtained from your users, right? Because if all of your users are experiencing your website well, who cares what Lighthouse thinks, right? If everybody's having a great experience, F you, Lighthouse. That's it. Let's go drink some beers.